Hello my dear students, welcome back to the session. Today we are going to discuss some problems on AC theorems, okay? See, we discussed DC theorems. What is the basic difference between AC theorems and DC theorems? You have theorems like superposition, reciprocity, Thevenin's, Norton's, yes or no? Okay? Tellion's theorem, Millman's theorem, maximum power transfer theorem. All theorem statements are same in both AC as well as DC circuits. But when it comes to maximum power transfer theorem, it is different for AC circuits from DC circuits. Simple reason that the load may be. Because the load, what is actually you're dealing with here in AC circuits, you're dealing with what impedances. And you know that the maximum power transfer theorem states that in the objective of the maximum power transfer theorem is to transfer maximum power to the load by varying the load. I hope you remember when we discussed in DC circuits. Okay, we want to transfer maximum power to the load by varying the load. But here the point comes that impedance. Impedance means what? It is a complex addition of resistance and reactance. So when the impedance is variable, different kinds of cases we can see. The first case is the load might be only resistive load. The load might be resistive or reactive. I mean, impedance is consisting of, load impedance consists of both resistance and reactance. In that, variable resistance, variable reactance, or variable resistance, fixed reactance, something like that. You have different cases, okay? And another important aspect you can see, the maximum power transfer theorem, whatever you apply in AC circuits, you are applying to average power, not for reactive power. Okay, the statement whatever you want to apply, you want to transfer maximum power to the load. What kind of maximum power you want to transfer? Do you want to transfer active power or reactive power? Active power you want to transfer, because we don't want reactive. Nobody wants maximum reactive power to be sent to the load, yes or no? Therefore, the active power deals with what? Active. What is the meaning? What is the meaning of active power here? The active power means the power consumed by the resistive element, which dissipates in the form of heat. Yes or no? So therefore, I don't want to discuss the Thevenin's, Norton's, Millman's, and all those theorems here, superpositions and everything, reciprocity. But I discuss here AC a maximum power transfer theorem in this case. Reason because this is the only theorem statement varies, okay, in AC circuits from DC circuits. Understand all of you? Okay. So you have a concept, definitely, the maximum power transfer theorem, maximum power transfer theorem, in AC circuits. Okay, in AC circuits. But in maximum power transfer theorem, the first step is always to replace the given network by Thevenin's equivalent. Agree all of you? This is plus, this is minus, no doubt. This is VTH. This is ZTH, which might be resistive, which might be inductive or capacitive. For convenience, I am just taking inductive here. Okay. Just for instance, I am taking inductive. It might be inductive or capacitive depending on the circuit. ZTH is equal to RTH plus JXTH. This is the load. Okay. Now load might be what do you have? Load might be only resistor, but variable. Load might be resistance plus reactance. Both are variable. Okay. Finally, load must be variable. Okay. The impedance might be consisting of the resistance plus reactance. But this is fixed, this is variable. Resistance, fourth case, resistance plus reactance. This is fixed, but this is variable. You understand? This is fixed, but this is variable. It looks like 4 cases, but I don't consider this particular case. The reason is you are keeping the resistance value constant. And maximum power transfer is applicable to what? Active power or reactive power? Do you want to transfer maximum active power or maximum reactive power? Maximum active power. I don't apply the theorem for reactive power. So obviously, when the resistance is not changing, then the active power is not changing. Yes or no? Of course, the power transfer to the load might be changing slightly because of the XL is varying, ZL is varying, current is varying. But the purpose of applying the transfer theorem to this particular circuit is to transfer maximum power transfer theorem for active power, but whereas active power deals with the resistance. Yes or no, all of you? Active power is the power which is consumed by the pure resistor component, but you are not varying this, then there is no sense or meaning in keeping this constant and this is variable, reactance variable resistance concept and trying to apply maximum power transfer theorem. It does not make any sense. Understand all of you? Okay, that is why I considered only 3 cases here. What is that? The load may be consisting of pure resistor. Yes, there is a possibility. The load may consist of both resistance and reactance, but both are variables. Third case is the load may consist of resistance and reactance, but reactance is fixed, but resistance is variable. It makes sense because the resistance is variable here. But the fourth is not at all a case of maximum power transfer theorem. It does not come under maximum power transfer theorem. It is something else we do not know, but we have only 3 conditions here. Okay. So the first case I deal with here, case 1. Okay, let me write case 1 here, something like this. The load consists of what? A pure resistor. Okay, and no doubt this is a variable one. Now, you obviously know that the simple mechanism of applying maximum power transfer condition or finding the condition for maximum power transfer is always express that active power in terms of what this variable and differentiate it and make it 0, first derivative, and then find some condition. Okay, so what is PL actually here? IL square into what? RL. But what is IL here? What is IL here? And I want only RMS magnitude. I don't require the total complex. So IL magnitude is VTH magnitude by root. Yes or no? So RTH plus RL whole square plus XTH square. Yes or no? Okay. This is what the current through the load. Yes or no, all of you? Okay. So total voltage by total impedance, but I'm just dealing with the magnitude. If you substitute here, then the total power PL is expressed in terms of only the RL is a variable. The remaining are there, but they are constant because VTH and RTH are constant. Yes or no? Okay. So square by RTH plus RL whole square plus XTH square into what is this? RL. Now dPL by dRL is equal to 0. If you do that, I am not really deriving that entire one. I hope you are all experts in doing the differentiation. Okay, so this is variable, this is also variable. It is like d by dRL u by v. Okay, so you know that already. What is that u by v when u by v is there? Okay, so therefore you will get, I'll give you directly that expression RL square is equal to RTH square plus XTH square. Then finally you'll get RL is equal to, okay, root RTH square plus XTH square. I call it magnitude of ZTH. This is what the condition for maximum power transfer. This is what condition for maximum power. Understand all of you? Okay. This is what the condition for maximum power. Then if you substitute this condition in this particular equation, okay, so equation 1, let us say, now if you substitute that RL in equation 1, then PL max will be VTH square into RL. What is RL actually now here? Magnitude of ZTH by RL plus RTH. That means RTH plus magnitude of ZTH, okay, whole square plus XTH square. This is what the maximum power that is transferred to the load. Getting all of you? Okay. So this is how you can solve and find the maximum power to be transferred. Some people do something like this. They apply this RL value or they substitute this RL value in this and they get IL which corresponds to maximum power. Understand all of you, okay? I find IL for which maximum power transfer takes place. That means I just apply RL is equal to magnitude of RTH in this and I find IL okay, for maximum power transfer. This is not IL max, this is IL for PL max. Then now that IL for PL max you substitute here and just multiply it with RL, then you will get PL max. So like that also you can do. There is no need to remember this formula. Okay, so please take down. Then we'll discuss next one is what case 2, where ZL is equal to RL plus JXL and both are variable here. Okay, so first you please note down that. Note down that, or else I'll complete it. Okay, I'll give you a time. Don't worry. Let us see both the cases now. So what is actually IL in this case? Tell me all of you. The formula is again the procedure is very simple. I want to find PL in terms of RL. Other than RL, there should not be any other variable. Okay, then differentiate that with respect to the variable. Now there are two variables. When there are two variables, the PL must be differentiated with respect to RL as well as XL. That means partial derivatives I'm supposed to apply. Okay, so let me see that. VTH by RTH plus RL whole square plus XTH plus XL whole square. Understand? So you got now PL is equal to IL square into RL. So what do you get? VTH square into RL by RTH plus RL whole square plus XTH plus XL whole square. I have just taken both are inductive actually here. Yes or no? Okay. Just for instance I have taken. But in your real problems, one is inductive, the other might be capacitive. Okay, anything it might be. So let me now differentiate. Now I differentiate dou PL by dou RL. Reason is there are two variables. When there are two variables, I think the best idea is what? To differentiate partially. Okay. So the partial derivatives when you apply, differentiation when you apply, when you differentiate it, you will get a RL is equal to RTH. So please all of you complete this. Okay, part on your own. You can differentiate it. You are all experts in differentiation, I guess. And another one is what? Dou PL by, okay, dou PL by dou XL is equal to 0. So you will get XL is equal to minus XTH is another condition you get. So when you combine these two conditions, okay, therefore ZL will become, okay, RTH. What do you get here? Actually RL plus JXL, but RL you get a RTH, then XL minus XTH. So minus JXTH. Okay, therefore this is nothing but ZTH conjugate. So complex conjugate of ZTH, okay, when you have ZL value, then you will get maximum power transfer condition. This is the condition for maximum power transfer. Okay, and if you substitute this in that power formula, okay, condition, RL is equal to RTH, XL is equal to minus XTH, this is cancelled, and finally you left with VTH square by 4 times RTH. 4 times RTH. Okay, so these are all the conditions for maximum power transfer and maximum power transfer to the load values. Okay, so please note down this. Hope you have finished this part. Okay, meanwhile I just do case 3. Case 3, right? Case 3. Now you have third case ZL is equal to fixed XL but variable RL, right? So this is fixed. This is fixed. So what happened here? If you have fixed reactance, since these two are in series, can I add or can I join or can I add this JXL with ZTH? Yes or no? You agree or not? Yes, you can. So finally you are left with something like this, ZTH dash. What is ZTH dash? ZTH plus JXL. And you are left with what now here? Only RL. Yes or no? So this is something like this. You got VTH something like this. Now, it is as good as the first case only. Once you modify that. Yes or no, all of you. Now what you do is, you know the condition for maximum power transfer when you have a pure resistive element, that is RL is equal to magnitude of ZTH dash is the condition for maximum power transfer. Condition for maximum power transfer. What is the maximum power transfer to the load, that is PL max? Okay, you will find what is the current through that, okay, at PL max. You can find that square into RL. I told you already what is this. This is nothing but current at the condition RL is equal to what? ZTH. Understand all of you? Okay. So this is very easy to find. There is no need to remember the formula. Or else you have to remember something like this. What is that? IL actually you have. Tell me. What is that IL you have? The IL will become VTH magnitude by root RTH plus RL. What is RL now? ZTH dash. Now in this case, whole square plus XTH square. Understand? RTH plus, okay, what do you get here? RTH plus, you have RL is equal to V by ZTH plus RL. Yes or no, all of you? In this, what do you have? Tell me. You have RL plus, what is this value actually? ZTH plus JXL. Yes or no, all of you? ZTH plus JXL. So what do you get here? RTH plus RL. Let me again confirm this. You got actual IL is equal to VTH by ZTH dash plus RL. Yes or no? So what is ZTH dash? VTH by RL plus RTH plus JXTH plus JXL. Yes or no? Plus RL. And finally you are left with what again? RTH plus RL whole square. Yes or no? XTH plus XL whole square. So therefore, XTH plus XL whole square. Understand? So this is what actually RL only. But since you apply RL is equal to ZTH dash condition in this, then this becomes IL for PL max. Understand all of you? Okay. So if you substitute this condition in this, then you will get IL for PL max. Then for that square, RMS magnitude square into RL will give you what? PL max. So please note down this third case. It's very, very important. Sometimes there are some restrictions imposed on ZL, that is RL and XL values. Okay, so let us look at that also, very important note, because some problems may come. So far, this kind of problems are not asked. Only up to this part the problems have been asked. But I told you already the IIT professor may ask the question in any direction, any dimension. So better we learn that also. That is also a very simple concept. Okay, so let us see now. First one, restrictions. Okay, I just write restrictions on ZL. That means it might be RL or XL or angle of ZL. Understand? Okay. Well, so first one, let us see the first restriction. Restriction on RL and XL. Then we will see, okay, the angle of ZL, something like that. We have some restrictions here. That means, no doubt that ZL is variable. The ZL is variable, no doubt. But he will impose some conditions or constraints on RL as well as XL. That means RL is variable only between these two. XL is variable only between these two. So what could be the most possible power that can be transferred? That means maximum power that can be transferred to the load. Under those conditions, you are supposed to find the maximum power transferred to the load. Under those restrictions. Understand all of you? Okay. So since RL and XL both are variable, okay, you impose the restriction or you first apply the restriction on XL. That means you set first XL, based on which you set now RL. Actually, RL is given, the restriction RL is given as RL belongs to RL minimum, okay, RL maximum. That means it is variable only between these two values. He is imposing a condition or constant or restriction. Now, XL is also variable between XL minimum and XL maximum. He will give the condition literally in the exam. When the circuit is given, he will mention that XL is variable only between these two values. Okay. So as usual, you know that when both R and XL are there, when both are variable, what is your condition for maximum power transfer according to case 2, right? Now case 2 is applicable here, no doubt. Now ZL is equal to ZTH conjugate. That means RTH minus J XTH. I guess you understand this. This is what the condition for maximum power transfer when both RL and XL are variable. So this is the condition for maximum power transfer. Now since both are restricted here, first you set XL, then you set RL accordingly. Understand all of you? Okay. So I do that. First, now from this I understand, this is already known that RL plus JXL is equal to what? Condition for maximum power transfer is what? RTH minus JXH. So therefore I understand RL is equal to RTH. That means I found now what is RL. Yes or no? Whatever the RTH value is there, that is nothing but RL only. Okay. I assigned that value to RL and I assign that minus XTH to XL, so that I get the values of both RL as well as XL. So these two values, if I maintain, no doubt I'll transfer maximum power to the load when both RL and XL are variable. But he is imposing the conditions or constraints, limitations or restrictions, whatever you call it. Now, considering those restrictions, what is the best possible way of transferring maximum power and what is that amount also we can find? Okay, so let us try to apply those conditions or constraints. Whenever conditions are given, there is a standard procedure in your entire engineering. In your entire engineering, there is a standard procedure whenever there is a restriction imposed on any particular variable. What is that? And remember, in this case, particularly, I fix first XL, based on which I fix RL. Okay, so let me just set that. You just write down here, since both RL and XL are restricted, set XL first and then set RL accordingly. It's very clear. Accordingly. You understand all of you? Okay. How do you set that? First, I set like this. If that XL is between XL minimum, okay, XL is between XL minimum and XL maximum, okay, no doubt XL will be remain XL only, because there is no need to vary that, because already it is variable between XL and XL min and XL max. Then directly I take that value as it is, and then okay, and from this I'll get RL also remain to what, or remain what, RL only, because when XL is minus XTH, then RL is RTH. That is the exact meaning of it. Now when you have XL remains XL, then whatever the value that RL you got, that RL remain RL only for transferring maximum power transfer condition when both are variable. You understand, all of you? Okay. But now if the condition changes like this is first condition, this is second condition. If XL is less than XL minimum, I hope you understand this. If that value, whatever you found there, is found to be less than the lowest value, then what is the best possible way of setting that XL? Better you set that value to XL minimum value only. This is nothing but enforcing the limits. When XL is going out of limits, you enforce the limits. What is the meaning of enforcing the limits? When XL is less than XL min, you call that XL is equal to XL min. When XL is greater than XL max, better you assign, you enforce that XL to what? XL max. This is the standard procedure in your entire engineering whenever you want to impose the limits on a particular variable. Okay. So this is how you are going to restrict. So what will happen here? When XL is XL min, understand? When XL is XL min, now you have this value is changed. Now RL will also change accordingly. What is that RL? RL is, I think you understand. Now you fix this XL. Now you want to find RL accordingly. That means it is as good as third case in your maximum power transfer condition what we discussed. What is the third case? Tell me. JXL was constant. XL was constant. Third case. Then RL was variable. Then you added that XL to what? ZTH. Yes or no? Therefore, you find that RL is equal to magnitude of ZTH dash. What is that magnitude of ZTH dash? It is nothing but ZTH. What is this here? What is this here? Plus JXL. But what is that XL value? XL minimum. I hope you understand the point. What is that value? XL minimum. I hope you understand the point here. Okay. So this is how you are supposed to handle the problem. So now what is the condition for maximum power transfer? In this case, RL is magnitude of ZTH dash and XL is XL minimum. Understand, all of you? Okay. Well, so this XL is nothing but what? XL minimum only, right? Now in this case also, now RL will change accordingly. ZTH dash nothing but ZTH plus JXL, where XL value is how much? Again, XL max only. You understand, all of you? Okay? This is how you are supposed to handle the problems. Okay. So once you know this RL and XL, you can fix those values in this particular circuit and find IL. That IL will become IL for maximum power transfer. Once you find IL for maximum power transfer, its magnitude square into this RL will give you maximum power transfer value. Maximum power transfer value. Similarly, this also you can apply the same way. This is how you apply, or you enforce, or the restrictions or limitations on RL and XL value. This is the only model so far not being asked in the GATE examination. So I'm expecting this year probably you may get the question. Okay, let us pray that the question must come here, because very few people can answer this kind of questions. The remaining cases anybody can answer. Okay, so please note down this quickly. Second restriction is what? The second restriction is magnitude of ZL is variable, Okay, so previous restriction was RL was variable only between two values. XL was variable only between two values. Now the magnitude of ZL is variable and angle of ZL is fixed. Okay, that means when ZL is equal to ZL at an angle of theta. Okay, so this is variable actually, but this is fixed. He's saying that this is fixed. You understand? Okay. Now, according to the maximum power transfer theorem, when you have a ZL, okay, when you have a ZL at an angle of theta, that is nothing but RL plus JXL. First, the condition for maximum power transfer is what? ZL is equal to ZTH conjugate. Yes or no? This is nothing but RTH minus JXTH. Clear? This becomes here ZTH at an angle of what? Minus theta TH. With theta TH positive, but minus theta TH is an angle actually here. So it's very clear for the maximum power to be transferred. Okay, for the maximum power to be transferred, ZL, what is ZL actually here? ZL must be what? ZTH, ZL at an angle of what? Theta. Understand all of you, okay? Theta L. Okay. If you don't have any restriction on ZL, then the condition for maximum power transfer is what? Magnitude of ZL is nothing but ZTH magnitude. And angle of theta L must be what? Minus theta TH. I hope you understand this. Getting? But since there is a condition that theta L is supposed to be maintained, okay, theta L is supposed to be maintained, therefore this is not going to be considered at all. Now the condition for maximum power transfer under this restriction will be, okay, ZTH, because that value is fixed, right? This is a fixed value. This is some 30 degrees, 40 degrees and so on and so forth. But ZL value we do not know, we need to find that. And that I find under the condition that ZL is equal to ZTH conjugate, from which I find ZTH magnitude. But I also know the angle, but I don't take that angle because already you are putting a restriction that you are supposed to take this angle only. Yes or no? Therefore, the condition for maximum power transfer will become, under this restriction will be, okay, under this restriction will be like this, ZTH at an angle of theta L. I hope you understand this. So condition for maximum power transfer. You understand all of you? You are supposed to take, as per the procedure, you are supposed to take ZL is equal to what? ZTH at an angle of minus theta TH. That is the condition for maximum power transfer. But what is the condition imposed? ZTH is variable, therefore ZTH. That means ZL is equal to ZTH. But theta L is fixed. So therefore I can't fix the theta L at minus theta TH. I take theta L remains same as whatever is given because I need to fix it according to the restriction given. That's it. So this is the condition for maximum power transfer for the given restriction. Understand all of you, okay? Do that, all of you? Do that? Note down that? I hope you understand. These are all varieties of problems that you can come across. So you must be thorough with the concepts, different cases. If you are thorough, I'm telling you, any problem that comes in the exam, you'll be in a position to answer it easily. Okay? Because varieties of questions are asked in the gate. Unexpectedly, the questions are coming in different dimensions. Okay? You cannot simply remember one model. Understand? Third restriction. Magnitude of ZL is variable and angle of ZL is variable between theta L min and theta L max. That means there are certain limits given here. Understand? Whenever these limits are given, again the same procedure. I think now by this time you might have understood. ZL is equal to what actually? ZL at an angle of theta L. ZTH is what actually? ZTH at an angle of theta TH. Understand? But condition for maximum power transfer, let us try to understand first of all when both are variable. Okay? Then what do you get here? ZL is equal to ZTH conjugate. Because when magnitude is varying, theta is varying. Even if magnitude is varying, theta is constant, then all of the real part, imaginary part, both will be varying. Yes or no? The angle is not changing. But you know that RL is equal to Z cos theta L, right? ZL. And XL is equal to what? ZL sin theta L. Okay? When magnitude is changing, RL is changing, XL is also changing, though theta L is constant. When both theta L and ZL are varying, then definitely RL and XL will change. That is why, look at this in case 2, I'm applying ZL is equal to ZTH conjugate. That case 2 I'm applying. Why I'm applying case 2? You may have a doubt, sir, angle is constant. Then why you are applying this? Yes, even though angle is constant, when you convert that into rectangular form, look at this. What is the real part? RL is equal to ZL cos theta L. XL is equal to ZL sin theta L. Though theta L is fixed, but magnitude of ZL is when it's changing, RL is changing, XL is changing, both are changing. When both are changing, what is the condition for maximum power transfer? Will end case 2, right? So what is that? ZL is equal to ZTH conjugate. Here also, the same thing I'm applying here, ZTH conjugate. Okay, nothing but ZTH at an angle of minus theta TH. So from this I understand clearly that because this is, we know ZL at an angle of what? Theta L. Therefore, you know that ZL magnitude is ZTH magnitude. I need to equate them, right? Condition for maximum power transfer. Okay, then theta L is equal to theta L, angle theta L is equal to, what is this? Minus theta TH. These are all the conditions for maximum power transfer as it is given. Getting all of you? This is as it is given without any restriction. Usually we take. But now let us, since here you can write in the previous case also, since theta L is restricted, then theta L remains same. Yes or no? That we maintain. Here also, since theta L is restricted, both magnitude as well as the angle are restricted here. Yes or no, all of you? Okay. Now magnitude of ZL is variable, so therefore I got ZL is equal to ZTH. But angle is variable now between certain limits. Understand all of you? Okay. So therefore, what I do is I just fix that ZL value is equal to ZTH, no doubt, but I'm worrying about this angle. Now, if okay, since theta L is restricted, if theta L is between theta L minimum and theta L maximum, then theta L remains theta L only. Understand? You got the point, all of you? Okay, well, if theta L is less than theta L minimum, theta L will become theta L minimum. If theta L greater than theta L max, theta L is equal. You understand? Okay. So you understand now theta L value is equal to minus theta TH, no doubt in that. So I fixed already what is theta L here. Okay. As of now, this is what theta L. But the theta L may change based on restrictions. If that theta L lies between the given limits, there is no problem. You take as it is. Okay. If theta L is less than theta L minimum, then the theta L will be changed to not to minus theta TH. It will become what? Theta L minimum. Similarly, it will become maximum. And finally here, the ZL becomes, okay, ZTH at an angle of what? Minus theta TH, the condition for maximum power transfer. And here, ZL becomes magnitude of ZTH. You understand? Magnitude of ZTH, but it becomes what actually here? Because it is, if it is inductive, then definitely that must be capacitive. So minus theta L minimum. Got it? Then if ZL, okay, in this case, ZTH, okay, minus theta L maximum. You understand all of you? Okay, so this is how you can handle with the problems when you have restrictions on ZL. So this is different varieties of problems that we can come across. Okay, then we will switch over to the problems on the same maximum power transfer theorem with some, okay, restrictions and without restrictions. So please do that. I just remove this part meanwhile. Okay. Note down that. Meanwhile, I just note on one problem here. We go step by step, simple problems to some complicated problems. Okay. I start with first problem with Thevenin's theorem. Note down that we have finished up to 34 problems. Okay, 35th problem we are taking now. Find VTH and ZTH values. Okay. J12 ohm, 4 ohm, minus J6 ohm, 8 ohm. Now he's asking what is VTH and ZTH between AB terminals. So 120 at an angle of 75 degrees. Hope you have done that, right? So go to the question number 35. We'll just discuss question number 35 now. Okay. So here the Thevenin's voltage and Thevenin's impedance. How do you find Thevenin's voltage and impedance? It's very simple, right? So how these two are connected in series? These two are connected in series. The total voltage applied for the series combination. This is plus minus V1, let us say. This is plus minus V2. Plus minus and plus minus, plus minus and plus minus. So what is V1 actually here? Because VAB is nothing but VTH here in this case. But VAB is what? V1 minus V2. So let's find V1. Okay, V1 is nothing but what? V1 minus V2, VAB. Capitals, okay. But what is V1 here? 8 by 8 minus J6 into 120 at an angle of 75 minus J12 by 4 plus J12 into 120 at an angle of 75. Okay, I think you have calculators, right? So you can simplify. I'll give the answer directly. 37.95 at an angle of 220.31. Okay, or else you may get this one in different angle. Note on that. Note on that. Minus 139.69. Or else you can get minus 139.69 volts. Okay. What is ZTH? These two are now, once it is shorted, these 2 points got shorted. So with respect to these two, no doubt these two are in parallel, these two are in parallel, then series. Okay. So I think you're experts in series parallel. I don't want to elaborate again here. We did a lot of exercise on that. Parallel plus 4 parallel J12. So you will get here 6.48 minus J 2.64 ohm. Okay. 36th problem. 36th problem. I read the question. ZL is equal to RL here, right? This is ZTH. ZS, okay. ZS he has given 10 plus J20. This is given as 50 at an angle of 0 volts. 50 at an angle of 0 volts, okay. Find RL for which the source delivers maximum power to it, and also find maximum power value. Okay, this is what the question. Very simple question. This kind of problems asked in many times actually in the KIT exam. Okay, so I think you have done this, right? Please note down that circuit first. Let me remove this part meanwhile. Okay, right. So what is actually the ZL here? A pure resistive element. So it comes to what the first case? It comes under first case. So under first case, first you replace the given network with Thevenin's equivalent. Already it is a Thevenin's equivalent. Yes or no? Therefore, according to maximum power transfer theorem, ZTH, I can call this ZS as what? ZTH only. Yes or no? Because this is a Thevenin's equivalent. So 10 plus J20, it becomes root 10 square plus 20 square. Yes or no? Okay. So what is IL? Now this is what the condition for maximum power transfer. Yes or no? So what is that value going to be here? I'll give you that value directly. This value is 22.4. 22.4 ohm is the condition for maximum power transfer. Okay. What is that maximum power value? For that I told you one technique. What is it? IL for PL max you find directly. There is no need to remember the formula. What is that IL for PL max? Just substitute here in this. This entire circuit will be now, okay, corresponding to what? The maximum power transfer. So whatever you find, that is corresponding to maximum power transfer only. So if you substitute this in this, so what you get here? 50 by root. Okay, what do you get? 10 plus 22.4 whole square plus 20 square. Now what is PL max? PL max. IL for PL max square into RL. Okay. What is IL 50 square by IL PL max is already there, right? 10 plus 20 whole square plus 20 square. Okay. Into what is the value? 22.4. So I just give the value here. 38.6 627 watt. Thirty-seventh problem. You can note down that, but read the 37th also. So 36A. Okay, 36A. In the above problem, if ZL consists of both variable RL and XL, determine the value of ZL which results in maximum power transfer. Also find maximum power value. Look at this. When both are variable, when ZL is consisting of both are variable resistance and reactance. So what is the condition for maximum power transfer? Case 2 or case 3? Case 2. So ZL becomes what? ZTH conjugate, yes or no? So what is that value now? 10 minus J20 is the condition for maximum power transfer. Is the condition for maximum power transfer. Now what is PL max for case 2? You know very well. VTH square by, that is 50 square by, already VTH is known. 4 times RTH. What is that RTH value now? 10. So this is what actually you get here. The value will become here 62.5 watt. This is how you solve it. Please note down that. They're all simple problems. We stop the session, and in the next session we discuss some more important problems, okay, on different varieties, okay, which are asked in the gate also.